And let's get started. So welcome again. Thanks everyone for joining. My name is Arne Wieberg. I work at CERN IT, and today's presentation for the topic of the day and the bare metal SIG will be on why and how we use Ironic in CERN IT. So just for those of you who have never heard about CERN or CERN IT, I will try to explain this in 1 minute. So CERN is the European Organization for Nuclear Research. The mission of CERN is to understand the mysteries of the universe, to understand what matter is made of and how it all works. And the main tool to do this is a particle collider, the Large Hadron Collider, which is a machine that is built 100 meters underground and has a circumference of 27 kilometers. So it's the largest machine ever built by humankind. And at 4 interaction points, particles are collided, and then there are detectors, as you see in the middle. Basically, these are big cameras to see what's going on when you collide these particles. They are each the size of a cathedral, roughly, and produce of the order of tens of gigabytes per second of data. And this data is then sent to CERN IT, where initial reconstruction of these so-called events happens. The data is also stored permanently and then distributed and fed into a network, a worldwide network of distributed computing centers all around the globe. Now, CERN IT itself runs at the moment like 1.5 data center, plus 1 actually. So the way I phrase this in this complicated way is that we have like 1 main data center at the moment, which is in Marin, close to Geneva. We host around 9,000 servers there. Then we have around 3,000 servers in containers, which are at one of the interaction points that I just mentioned. So this is the half a data center. And then we are about to create a new data center, which will be built in the next couple of years, where we expand our compute capacity. Now, CERN IT, since quite a while, is a heavy user of Openstack. So we have a deployment in production since about 2013, currently with around 8,500 hosts with 300,000 cores in these data centers that I just mentioned. We run 35,000 virtual machines in about 80 cells, and cells we mostly use for scalability, but also to separate different use cases, to separate different hardware or power feeds and also location. We also run multiple regions, also mostly for scalability, but also in order to test new features, for instance. And OpenStack at CERN supports quite a wide range of use cases. So there's the real compute that we do in order to analyze the data, but also IT services in the experiments, but also administrative services are hosted on OpenStack. And the control plane of OpenStack itself is also hosted on OpenStack. These are virtual machines that run on our infrastructure. And then we have also, like in the middle here with the bear, we have Ironic since a couple of years, and this will be the main topic now. So why do we use Ironic, or why do we use a bare metal management API in CERN IT? So this, of course, follows a little bit the infrastructure as code paradigm. There was always at CERN IT, there was always the need, in addition to the VMs and the container offering that OpenStack provides, to also provide physical machines. My favorite example is experiments that try to tune their experiment code, and they cannot afford to have or to do this on a virtual machine where the performance fluctuates and maybe fluctuates more than the tuning that they do. So with Ironic, we streamlined the resource provisioning. So the user basically creates physical machines the same way as the user would create virtual machines. So we use the identical approval and provisioning workflow for both virtual machines and bare metal nodes. And the reallocation of physical machines, so the transferal of a physical machine from one user or one user group to another, is reduced to flavor access in the corresponding OpenStack project. Since we run OpenStack since quite a while, several groups have built tooling for VMs and use the API in order to create or delete virtual machines. And one example is our main user, which is the batch computing service. And they can leverage this tool chain that they have built now also for bare metal nodes. Since Ironic provides the same APIs, or allows to use the same API for virtual machines as for bare metal nodes, they can use or basically transfer this machinery now to physical machines as well. Another issue that we had is accounting. So we needed to know who is using how much of our resources. And before Ironic, the sources to feed into the accounting were split because they were coming from different sources for virtual machines and bare metal nodes. Since now everything is based on OpenStack projects, the source for the accounting is the same, and this simplifies the accounting a lot. And while Ironic was initially mostly for provisioning, so it was mostly how do we give out or hand out physical machines to users. Meanwhile, it has grown into a framework that we use in order to revisit the whole lifecycle management tooling that we have. So the idea is that rather than relying on downstream tools and mechanisms that we have to use the upstream framework and just add customized plugins into it, and this way reduce the overall maintenance for us in CERN IT. So when I talk about the server lifecycle management, what do I mean? So as you can imagine, when we order or when we install new servers, after we have ordered them and they arrive at CERN IT, they're installed into the racks. There's power that's being connected, network that's being connected, and then it goes through this cycle of different steps throughout the life cycle of or throughout the life of such a server. So there's the initial registration with various databases that we have at CERN. So this is for very new or for completely new machines. We do a health check at the very beginning. So we check, are there enough disks? Are all the CPUs there? Is there enough memory? Then we burn in these servers for quite some time. So we do a CPU burn-in, memory burn-in, disk burn-in. We also check the network and transfer over the network to see that the NICs work correctly. And then in addition, we also benchmark the servers because we usually buy compute capacity per cycle, if you like. So we buy the most cycles for the mining. And we need to confirm that this is actually delivering what we expected and what we bought. The servers are being configured and then they are provisioned to the user. So this is the step where we hand it out to the various services that we have. There's also a step which I called adopt, which is not Ironic adoption, is more like incorporating existing servers. I will mention this in a second. And then, of course, the servers are with us for a couple of years, so there's repairs, so things break, disks break, memory breaks and needs to be replaced. And then at the very end, the nodes are retired, which basically means to remove them again from the data center. And at this step, they also can go through some lightweight burn-in again in order to be donated, for instance. So as you see, I've marked these various steps with a bear. So the full bear is basically where we have Ironic for this specific step in full production, like the benchmarking, for instance, or the provisioning. And then there are some steps where we are working on integrating either upstream features, for instance, here for the auto registration, or where we're working on something like the burn-in at the moment. So to have one example of these steps is the auto registration and enrollment that we're currently working on. So this is why I've marked this as work in progress. So this is basically what happens at CERN if you, or what I plan to do for a new server that arrives in the data center. So when the node powers on very early on, it basically sends out a request and says like, okay, I sends out DHCP requests in order to understand what it needs to do and where it is. The DHCP infrastructure and the PXE infrastructure, so AIMS is a CERN downstream tool that is providing the PXE infrastructure, PXE and TFTP, will reply and will provide the node with an Ironic image, which boots the IPA, so the Ironic Python agent that's inside this image. It runs the initial inspection and then sends data to Ironic, to our Ironic infrastructure. Ironic doesn't know anything about this node yet, so it will start enrolling it into its own database, and it will also add it to other databases, in our case, a network database that's called LANDB, which is basically, it's a network database where you have some of the networking information that's like specific to CERN. And then it sends this introspection data, which is information about what types of CPUs are there, the RAM, the disk, PCI devices, and so on. and sends this to S3, which in our case is hosted on Ceph, and it can be extracted from there into OpenDCIM, which is an inventory management tool where you can visualize the room layout, the racks, and the individual machines, and can get access to this information that Ironic has collected. So this is one example of these steps, and the other steps that I mentioned earlier, all these steps look somehow similar in that respect. So this is an example of another step, which is retirement. So it's not to explain the step, it's more like how it looks like from the Ironic point of view. So this is something that we did last week, where we retired 1,600 servers from the data center. And you can see here over time the bare metal events. So this is what Ironic sees when we retire 1,600 servers. We did this in chunks in order to make sure we don't overload Ironic, because it's the first time we actually retire that many machines from Ironic. And you can see it's in chunks of 200 and then 400 and then 1,000 nodes. And you can see that first there's always like two steps. One is to like set the retirement flag or mark a node for retirement, and then the actual cleaning. So this worked quite well, and this way we retired these 1,600 servers, and Ironic actually managed to do this quite well. This plot shows how we grew Ironic at CERN over time. So you see we started at the end of 2017, and then whenever there's like new deliveries, you see it climbs up a little bit. And then during 2019, we actually decommissioned a whole remote data center that we had. And all the equipment, or most of the equipment, was relocated to the main data center that we had. And we took this opportunity to re-import these data into Ironic. This is why in 2019 it was going up quite quickly. So ignore the spikes here. This is just a monitoring artifact. So it's not like we have, I don't know, 2,000 nodes and then we take them out again. So this is 2019. And then we have in end of 2020, beginning of 2021, this very steep increase here. And this is due to the adoption that I mentioned earlier, where we integrated production nodes that we had before Ironic into Ironic. So the idea here being that for services that had nodes that were already in the data center before Ironic was there, they can now manage them the same way as all these servers that they have bought since Ironic was introduced. So this was actually done transparently. So without any reboot or anything that the user noticed, we moved these machines into Ironic, made Ironic aware of these machines, gave Ironic the corresponding credentials, and also updated OpenStack and OpenStack Nova in particular to know that there are now physical instances with which the users can interact. And then it's flat because we didn't have any new deliveries or retirements. So this is taken right before the retirement that I just mentioned. So we'll drop here by 1,600 nodes. And I think that's it already. So this is why and how we use Ironic at CERN. And with this, I'm happy to take questions. If there are any.
So I had one question from the networking point of view. Mm-hmm. Since you're moving the nodes from one user to another, how do you handle the the network isolation?
Right. So networking is a little bit special because networking at CERN, at least for Ironic, is a big no-op. So the database that I mentioned beforehand, this LANDB database, basically has this networking information. And Ironic and OpenStack for bare metal nodes do not really touch this. They basically work around this. So there's basically no changes when it comes to the networking, really. Also, there's no real separation. So we only have one flat network for everything, which makes it simpler. But it's because we're not a public cloud provider that needs to that has users that need to be strictly separated. We don't have this requirement.
Got it. Do you have a separate network for managing the servers from the user networks on a physical layer, or is it all physical and then you?
So yeah. So all servers have of course two interfaces. Well, there is basically the management interface, which is connected to the BMCs, and then there's the data interface, and these are usually the only two that we have. So these two are of course separate, and these two are also like well, they're physically separated, and also like the access is separate. But the most servers, or the majority of the servers, only have one data interface, so there's no additional separation. I don't know, like a provisioning network, for instance. So this is only one, but we have a separate management network, of course.
So basically, all of the servers are on the same kind of user or
Yes.
data networks.
Yes.
So it doesn't matter which user is using it. Does it's all clean. Okay.
Yes.
Got it. And there is no securities on requirements on that space.
No, not really. So for the new data center that we're planning, we may change this. The nice thing, of course, I mean, it's less secure, if you like, but it's also more convenient because it's very, very simple. So there's no like confusion about different networks. For the new data center that we built up, because for this, of course, Ironic came much after the data center, all the servers were already there. So it was not, and also OpenStack, in fact. So it was not actually designed for this. For the new data center, that may be different. And we may consider to have like separate networks, which is like a more standard deployment.
Thank you.
Arne, can you speak about which management protocol you use and what your plans are around that?
Yeah. So
actions with baseboard management controllers, BMCs, such as, well, in our case, at Deltek, the iDRAC.
Right. So when we order servers, that usually has to go through a public tender, and we have a specification document where we describe exactly what the servers must be providing. We use IPMI, so we have the BMCs, of course, and then we require IPMI functionality in a certain version or to interact with the servers. The majority of things that we do with this are relatively simple. So it's like basic Ironic functionality, like power on, power off, reset, set the boot device. So this is like what Ironic needs, plus console access. Because if you deal with physical hardware, you are very often in a situation where you need to have a look at the console in order to do this. Console access at the moment is basically relying on the web console that the BMC provides. So it's IKVM based in most cases. And we have a small patch that would actually report the access and the credentials to the admin in order to actually get access to the console. So it's a very manual process to get to the console. But these are the main functionalities that we use, and it's all relying, or mostly relying, on IPMI and the web console. Now, for more recent deliveries, we have also been started to look into Redfish in order to do some of these things. So I have actually successfully booted or deployed a node with Redfish that is working okay. We've started also to look into console via Redfish. That seems to be a little bit more difficult. So what's relatively straightforward to do is, if the corresponding BMC provides this, to get a URL where you can get to the IKEA VM. So basically you say OpenStack bare metal node console show, and it will give you a URL. You click that URL and the browser opens a window with the console, which is already quite nice and very similar to what we do with virtual machines. We have also tried to use KVM IP, but did not succeed to do this yet. So Redfish would allow you to get at this information, but we were not able yet to actually open a console with this. So the plan is we're looking at Redfish as a successor to IPMI in order to leverage this kind of additional functionality. So this is like the midterm to longer term plan to move to Redfish. But at the moment, in the specification that I mentioned early on, we don't have specific requirements in terms of Redfish yet, because we don't really know what we need to ask for. This is also why we participated in the interoperability profiles work that Richard and his team were mostly driving, to basically have something where we can say, okay, look, this is the kind of functionality that we need from the Redfish interface. for servers that are in the CERN data center.
Are you looking at using Redfish to configure BIOS settings, to configure RAID, out of band, and also
right. Okay.
the firmware versions are installed on the bare metal systems?
Right. So so all of these are, of course, functionality that we need. So we don't have, or we have very little hardware RAID. And we got rid of this a couple of years ago and mostly rely on software RAID. This is also why we added this to this functionality to Ironic. So the vast majority is running on software RAID. But of course, we need from time to time change BIOS settings. So for instance, when we had the L1TF vulnerability a couple of years ago, this may require to change the server settings from, I don't know, switch on or off hyperthreading depending on the use case. And if we had an interface to do this, that would be, of course, very nice. So this would be something that at the moment is quite a manual process. So that would mean to run proprietary tools that can change the BIOS settings or to boot in a specific run this image in order to change this. If we could do this via Redfish, that would, of course, be another selling point. Yeah, so this is something that we don't have at the moment, but it's something that we have other tools for this, but this is of course an area where Redfish could probably help. But as discussed previous occasions, it can be quite difficult to do BIOS upgrades for depending on the tools, depending on the mechanism that is used, depending on the implementation of Redfish by the various vendors. Yeah, I'm not clear yet on how, let's say, consistent this will be, the experience in that area, in this more like sophisticated areas of Redfish.
Thank you, Arne.
Any other questions? There's something in the chat. Okay, this is like all these questions.
Yep.
Okay.
Thank you very much, Arne. Much appreciated.
My pleasure. Okay, if there's something else, thanks everyone for joining, and see you next time maybe.